Gosolica 1273 delete tree nodes. They give us a tree. This tree is using uh, number nodes. That means how many nodes it is from 0 to nodes minus 1. Those kind of nodes number. And for every node, it has a parent. So it uses this node number and also the parents array to represent tree. And also for each node, it has a value. So what we do is that we are going to delete all of the subtrees which has sum equals to 0. For example, the node this node 3, right? Each itself is 0, so we need to delete it. And also this subtree is sum up to 0, right? So it will need to delete it. So it asks how many nodes left? So there is two nodes left. So return two. So first thing we want to do is that we should use this kind of integer parent array to compose this one as a map or list as a tree so that we can do DFS, right? So for the DFS, this one, what we're thinking about is that intuitively we'll see this tree is not a binary tree, it may be an tree, right? So for example, this is a map. So what we do is that for this tree node, if we already have some values of all of these child trees, this should add to our current one, right? So, but the thing is that we want to calculate. There are two things we need to calculate. One is the sum, right? Another is valid count. So so for so the thing is that if what we do is that for example if this child it has sum to be 0, right? And it counts it may not be 0. For example, it have 15 nodes under this child node, right? So what we do is that we should not contribute to our parents. So we have we can do a trick way is that if we have sum equals to 0, we instead of not set this count add to our parents, we just set this count equals to 0, right? So that for our child our child with DFS, if the sum equals 0, it just return the counts. No matter what is the subtree nodes, it will return 0, so it will not contribute to its parents. And in the end, we DFS to the root, for example, root 0, right? We DFS root 0, just return this array's count, right? So because we have the logic, even if this one it is self counts to 0, all of that will be deleted, so it will be return 0, right? So let's write code for this. First, we need to compose the tree. We set arrays, set all tree, new array list. And what we do is we from the parent array, right? We compose this tree. So if parent equals -1, we should continue, right? And otherwise, we just have tree parent I a I. So we'll say for this DFS, it will return two results, private int DFS, right? So the result 0 will be the sum, okay? And 1 will be the count. And also, after uh, we return, before we return, before return this result, we'll have this condition if sum equals to 0, we set count equals to 0, right? Just clear that, so that it will not contribute to its parents. So what we do is that DFS, we need to have this tree, right? And have root. And also for this one, we need to pass in the value to calculate, right? So in the end, just return um, result there, result one, right? Because we want to see what's the count left. So we need to have at least the integer as tree and the current node and also the entire value, right? So we know into this result equals new into uh so it will have two values, right? The first is the sum because we need to contribute to the total one, right? So we should have value current and also current root. Let's say it has count one, right? So what do we do is that for every child under uh tree current, right? So we have answers equals DFS tree child value, right? So so that means that for this one, if sum already equals to 0, right, it will become 0. So we can safely, we don't need to check if this one equals 0 or not. We just safely as result 0 add equal to answers 0, right? And result 1 should add equal to answers, right? So before we return, we'll write if result 0 equals 0. So let's set it to count also equals to 0, right? So in the end, just return result. Let's take a look. Tree current for each child. So result 1 equal to 0, right? So this one for each node we iterate once, so it will be O n time complexity in the what's the OH space if we consider the recursion, right? Um, let's also write a Python code for this. So we have a tree equals for underscore in range nodes. So what we do is that for I in range nodes, we're going to have if parent I equals -1, we should continue, right? Otherwise, what we do is that we need to have a tree parent I append I. So let's define the DFS. DFS. So we should have current int. So this one will return this int. So we'll say we'll have total sum, right? Total, total, and the count. Total equals value current. Count equals 1, right? So for child in tree current, so we'll have a child total. Mm, child total, and then child count equals DFS child. So we'll have a total to the plus equal to child total, and count the plus equal to child count, right? So before we return, we'll write if the total equals 0, we need to return 0, 0, right? Otherwise, we just return total and count. And in our main function, right, we should also call this DFS. So we'll have, for example, this one, result equals DFS 0. In the end, just return result